Today we will talk on bearing capacity of soil when we determine for the foundation design of the buildings in context with the climate change. K and Fund, former ADB Secretary. When we talk about the climate change, we say that climate change is long-term shift in temperature and weather patterns. Now, these shifts may be natural due to changes in sun's activity or large volcanic eruptions, and due to human activity also. And that is primarily due to burning of fossil fuels like coal, oil, and gas. Now, burning fossil fuels generates greenhouse gases, and these emissions that act like a blanket wrap around the earth, trapping the sun's heat and raising the temperature of earth. This we know, and we also know that the main greenhouse gases that are causing climate change include carbon dioxide and methane. Now, uh, we also know that these gases come from using the gasoline, that is petrol, diesel, etc., gas for driving vehicles, or also when we use coal for generating the energy, whether it is in thermal power plants or in houses or anywhere. Now, these greenhouse gases uh, also come from clearing land and cutting down forests. Why? When we cut the forest or clear the land, that is greenery, then naturally the trees that tree, you know that they consume carbon dioxide and give oxygen. So when these are not there, forests are not there, trees are not there, greenery is not there, then carbon dioxide will be released, that will not be consumed. So naturally, greenhouse gases also increase. Okay. Now, agriculture, oil and gas operations are also major source of methane, and that we cannot stop. So, agriculture will require always will require the development. Then also we must understand that as the population will increase, we are going to clear the land, and then when we are going to clear the land, then maybe that some of the trees also cut down. Then also in the name of development, the greenhouse gases will continue to increase. Okay. Now, energy, industry, transport, buildings, agriculture, and land use. These are considered among the main sectors which are causing greenhouse gases. Now, energy will require, though we are shifting from conventional energy to renewable sources. Industry also, we are trying to switch over, also in transport, in buildings slightly, and then in other areas also. Then, but let us understand that this cannot be zero. So these greenhouse gases will remain, and what we want is to minimize the quantity of greenhouse gases. So net zero effect is there. Now, what are the consequences of climate change? See, I'm not going to discuss the climate change basically. I am to discuss the bearing capacity of soil with the effect of climate change. Now, the consequences of climate change may include intense droughts, water scarcity, severe fires, rising sea levels, flooding, and so on. Now, see, you see here that flooding is there in the consequence of the climate change. And what will be the effect of flooding in the state bearing capacity of soil? Let us understand. Now, when we talk about the flooding and building, then buildings, they are designed for foundation and superstructure. And you see, if foundation fails, the building will collapse. If superstructure part of the superstructure fails, that part will collapse. But if foundation fails, then the whole building will collapse. Now, foundations are designed based on uh, safe bearing capacity or allowable bearing capacity of soil below footing. That everybody knows. Everybody knows that foundations, type of foundation also, and then the how much bearing capacity, what we can say allowable bearing capacity with the settlement and principle, or otherwise say bearing capacity. So it is to be determined, then only we find out the foundation. We will design the foundation. And we know the safe bearing capacity or allowable capacity of soil below the footing. Now, bearing that also we know that bearing capacity gets affected, rather gets reduced with water table close to foundation. Suppose at present the groundwater table is not joining the foundation level, then we will not apply the correction water correction factor. But in case the water table rises or water is there below footing, then we are to include water correction factor, and if we apply water correction factor, then we know the bearing capacity gets reduced. Now it means that by any chance if there is a flooding and then water table rise is there, and we had not earlier considered while determining the bearing capacity, then it means the bearing capacity of soil will reduce, and reduction means that the building foundation may get fail, may fail, foundation may fail, and ultimately the building will collapse. So water level due to flooding will lead to rise in groundwater table, even suppose temporarily, and then this will reduce bearing capacity of soil. That is important. And even suppose fine sand is there, and earlier water table was not there in the vicinity of the foundation, then that also may get liquefied because fine sand is already there, and then additionally what is required is only water and fine gauge soil is there. So if the conditions of seismic conditions are there, what earthquake comes, then maybe that the foundation collapse. So, flooding due to climate change, if there is any flooding due to climate change, then this will lead to two conditions. One will reduce bearing capacity, if not considered earlier. Two may lead to liquefaction potential in case of fine sand in severe conditions. It means that the foundation may fail due to flooding triggered due to climate change. So, what are the recommendations? It is therefore recommended that all the buildings, and if not all the buildings, at least all multi-storied buildings should be designed as they have so many people inside the buildings and they have large flat. So all multi-storied buildings should be designed considering groundwater table at the level of footing, as we don't know that today the water table, groundwater table is not there, but with climate change the conditions will change, and there may be natural rise in natural groundwater table also, or there may be uh, groundwater table, sudden temporary groundwater table rise due to flooding. So in case of fine sand is available below footing, foundation should necessarily be designed for liquefaction potential even if dry conditions are available.